Our second example starts with another inequality. 6 minus 5y is greater than negative 9. So what did you do here to try and solve this inequality as an inequality? Subtract 6. Again, if you think about the same steps as you would do if it were an equation, that leads you to reversing the order of operations. Take care of the additions and subtractions first, and then take care of any multiplications and divisions. So subtracting 6 from both sides gives me a new inequality. Negative 5y is greater than negative 9 minus 6, negative 15. Okay. And then what? Dividing both sides by negative 5. So if I divide negative 15 by negative 5, I get positive 3. Aha. Okay, right. So this, when I say I want to dwell on what's different about this example, this is a step where we have to do something different. The step itself of dividing both sides by negative 5, awesome. Totally the same as if this were an equation. What's different? What did you say was different about this that we need to do? You also switch the inequality around. So now, Jordan, I have to ask you, how did you know, what is it about this step that we just did that told you I should switch the inequality? Which negative? Yes, right. So here's the thing about inequalities. Inequalities are sensitive to the ordering of the numbers on the number line. Anything we do to both sides of an inequality that preserves that order, we don't have to change the sign of the inequality. So if I'm going to add a number to both sides, all that does is it takes the number line and it just sort of shifts it in one direction or the other. So if I were to subtract 5 from this number line, it would just have the effect of shifting that whole number line over to the left, for example. That doesn't change the ordering of the numbers on the number line, so I don't have to change the sense of the inequality. Same thing with adding a number. Same thing multiplying a number that's positive. But if I multiply or I divide by a number which is negative, it's going to take all the numbers which were positive on the number line, it's going to make them negative. It's going to take all the numbers that used to be negative and make them positive. So what does it do? It flips the whole number line around when I multiply or divide by a negative number. And so because the whole number line is flipping when that happens, we have to flip the sense of our inequality as well. So this is the one step that makes the solution process different than if this were just an equation. So this is the except. All the steps are the same as an equation except when multiplying or dividing by a negative. Flip the inequality. Flip the inequality sign. So where our inequality was greater than, once I divide by a negative, that inequality becomes less than. So the inequality which solves this problem, 6 minus 5y is greater than negative 9, is the inequality y is less than 3. Let's talk about the graph. How would I convey y is less than 3 using a sketch on the number line? Let's say I put 3 right here. And maybe this is 2, 1, 0, here's 4, negative 1. So what should I do on this number line to convey the idea y is less than 3? Okay, so I'm going to put a symbol at 3. But now Jordan is saying we want this to be an open circle this time. Why? Because we don't want 3 to be a part of the solution here. If I were to plug in a 3 for y in my inequality down at the bottom, I would get 3 is less than 3. Is 3 less than 3? No, 3 is equal to 3. So 3 is not included in this solution. And so that's what we mean when we say an open circle. 3 is not included. So if we're tracing the through line here, having a strict inequality, less than, rather than less than or equal to, correlated to us having an open circle on our sketch on the number line. And then what else besides that open circle do I want here?
A line to the left.
Yeah, again extending to the left because we're thinking of all of the numbers which are less than 3, so that includes 2, 1, 0, negative 1, as well as all of the non-integers in between those values. Shade everything to the left because that's going to cover all the values that are less than 3. Great. So there's our graph, and I think I'll finish this off by putting a little arrow on this side of it. Just to indicate that that continues on. Okay. And if that continues on to the left, then in my interval notation, what is going to be my lowest point? Yeah, again, because there is no smallest number, which is included in this solution, negative infinity is our lower endpoint for our interval notation. What's my upper endpoint? 2. Everyone agree with that? Somebody think of an example of a number which is included in our solution, but which is bigger than 2. But 3 is not included in our solution. 2.7. So there's an example of a number which is bigger than 2, and yet it's still a part of our solution. So if we say that our interval stops at 2, we're missing some stuff. So should we just move it up to 2.7? 2.9? What about 2.95?
Put a round bracket
There we go. Put a round bracket around what?
the 2 and the infinity sign.
Okay, so we know we need a round bracket around the infinity sign because that's always the case for infinities, right? But if I put a round bracket around 2, I think we're still missing some numbers. Right? We're missing 2.5. It wouldn't be in here. What this is saying is we go all the way up to 2 without including 2, but then we stop. So we'd be missing 2.5 and 2.7 and 2.9 and 2.99 and 2.9999 and 2.9999997148992, right? We'd be
Put a
missing
2.99 on the line over.
We could do that. Let me ask Mel, the math major in the room, the other math major besides me, I suppose. What is 2.99999 repeating? Putting her on the spot. Actually, I disagree. It's rational. In fact, what do we know it? What is it better known as? What'd you say? I thought I heard somebody say it. 3. Yeah.
Oh, wait, so
3.
then you just put a round bracket around 3?
Yes, thank you, Jordan. Yes,
Okay.
exactly. That's what we do. Yep. We go all the way up to 3, stopping at 3, but not including 3. But 3 itself is the only number that we don't include. Everything which is even the slightest bit less than 3 will still be included when we write the notation this way. So it's not something we have to overthink. That's the good news, right? We overthought it just now, and that's the last time we'll need to overthink it for the semester. It stops at 3, and the round bracket tells us that 3 itself is not included. And that's all there is to it.